Hello everybody, this is our Senior Design 2 Progress Report, and we are team number 14, and our project is Power Pulse. So Power Pulse is a home energy monitoring system, and it's designed to provide homeowners with real-time insights into their energy consumption. So we've actually been able to finalize the circuit design, and we've coded the device to connect to Wi-Fi and transmit data to the cloud. Just to go over a quick overview of our progress, a couple of changes from our last update, and we actually completed building the REST API and app interface to be able to view data from the database, and we've actually also added a feature where we can update the code wirelessly through Wi-Fi. So going into our progress, so we have our test and production builds where we have two separate devices measuring and displaying data in 3-second intervals. And then we have our cloud integration where our devices connect to Wi-Fi in a secure way and they're able to send data to our AWS cloud. And then finally, we have our app development, and this is where our app GUI is done and our API is almost done. It just needs to be connected and checked.
Of course, we have an overview of our circuit design. It features the 2 transistors and 1 capacitor, which store the energy that the CT sensor collects. It actually feeds in power and amplitude data from the current to our ADC GPIO, to the ESP32 microcontroller. The ESP32 microcontrollers are a central processing unit for the hardware. It is also connected to an LCD screen that shows more immediate feedback, whereas the cloud environment shows more over time feedback. And the ESP32 is powered through USB and supplies the 5.5 volts to the sensor and 3.3 to the LCD screen. So as far as our embedded software environment goes, we're using Platform IO, which is very similar to Arduino, and we are using C++ as our programming language because it is very low level and allows us a lot of control over our hardware environment. Measurements are taken every 3 seconds, and they are loaded into an array that is parsed into a JSON format that is transmitted to the cloud every 2 minutes and 30 seconds. So this is a high-level view of our cloud architecture. This is not the exact diagram that we're going with. We have a few changes that we've made. So we have the sensor that gets uploaded to the IoT environment, and then the information is saved in the DynamoDB database. Now we have the data in the database. It gets archived every 7 days into an S3 bucket, where we do that to save money. And then we are at the API gateway stage. That is where the data that is in the database, or we can use the S3, we can parse it into a JSON file that can be sent to the front end. Now, in this case, they're using a website, but we're using a mobile app. Now, here is a look at some of the screens from our GUI. As you can see, we have several panels to show different readings: power factor, power frequency rating. We have a line graph to show power over time. Then see, we're using AWS Cognito for our authentication to make things simple, keep everything in the AWS environment. And for our coding language for the app, we're using React Native because it is cross-platform, meaning it works on both iOS and Android phones. This is a current update on our timeline. We are actually keeping up with everything that we originally said. Yeah, we do hit snags every once in a while, but despite that, we are able to deliver at each and every turn. And here are team contributions. So I have built the hardware and code implementations. Antonella, she's in charge of theoretic design and analysis. And Matthew Moreno is in charge of the abstract, circuit analysis, and calculations. And it looks like it succeeded. We have our status code 200 and our body with data, and it's giving us real data from the database, and each device has a assigned name to it. So right now I just have one device that's transmitting here. It has power pulse 0, and with each measurement we ended with a power factor, and we end up getting a daily average power factor and a power factor for each measurement.